So welcome back, superstars. Today, you're with Zach, and we'll be discussing AP Chemistry Unit 1, Topic 5. So first, I'm going to kick this off with a brief discussion of Coulomb's Law, which is an equation we can use to find out the attractive force in between two particles. So throughout chemistry, this is generally going to be used to represent the force of attraction between a proton and an electron. So in this equation, we notice a few things. So first of all, you're dividing by the radius, or the distance between the two particles, or the radius squared, which means that radius is inversely proportional to a force exerted. So what that's saying is we can basically deduce that if this radius went from r to 2r, then your force would be divided by 4, because it's it's divided by r squared, showing that as the distance increases, your force decreases. Okay, so also in this equation, you notice your Q1 and your Q2. These Q values are generally to represent effective nuclear charge, which means basically just the amount of protons an atom has, which this basically shows, like, if I were to compare Q1 being 1 to Q1 being 100, you get a higher force if the distance stays the same if the Q is 100. So I'm basically saying that as the amount of protons increase and distance remains constant, the force exerted will increase. Also, if you're confused, this sign represents proportionality. So in AP Chemistry, we won't necessarily have to calculate using this formula, and it's kind of just here to help understand the concept and the relations between distance, force, and amount of protons. So next, I'm actually going to go to this slide of notes I made called distance versus shielding, which shielding I'll kind of get into in a minute, but I've pointed out basically 3 electrons of varying distance from the nucleus. So we have electron 1, electron 2, and electron 3. And these little lines are kind of representing the distance and the force. So F1 or D1, and then F2 or D2, and then F3 or D3. So as we see, this is the smallest distance from the nucleus. So distance of F1 is less than distance of F2, which is also less than distance of F3 from the nucleus. Which, since, as we previously mentioned with Coulomb's law, as your distance increases, your force exerted decreases. So now we know that the force of the nucleus so the force from the nucleus being exerted on electron 1 will be higher than 2, and 2 will be higher than 3. Okay, so as we previously kind of just mentioned, distance is kind of going to be your main argument as to why one electron will have less force exerted on the other. However, there's another concept that I'm not entirely sure if you actually need to know for the AP exam, but I'll still discuss it. So these electrons are all in different shells, and the distances I'm trying to show are the distances between shells. So distance 1 is from the nucleus to the first shell, distance 2 is from the first shell to the second shell, and distance 3 is the second shell to the third shell. And they increase. This is basically because of these little arrows here, which are the repulsive forces between electrons. So electrons all exert a negative charge, meaning that they're going to repel from each other. And the more, basically, these electrons are all repelling from each other, meaning that this last electron, say that you only have this is like your valence shell, it will be the furthest out because it's the repulsive force from all the other electrons being exerted onto it. And a really, really, really important thing you need to know for the AP exam is that you need to use distance generally as your main argument when you're talking about the force exerted on particles, because it plays a bigger role than shielding, generally. So next up, we're going to be discussing atomic radius. And the periodic trend you probably learned in honors or normal chemistry is that as the radius increases down periods, and then it increases across them, or it decreases across them. And a super important thing you need to know about this, or how to understand this, is, so we learned that the radius will increase every time you go down a period, generally. And this is because every time you go down, you're adding an extra occupied electron orbital, which contributes to a higher distance between your nucleus and your valence electrons, meaning that your atomic radius is longer. And then atomic radius decreases across because what's happening is, here, let's refer back to Coulomb's law. Across a period, you're not adding an extra electron orbital to contribute to the distance, but you're actually adding protons. Therefore, your effective nuclear charge is increasing, which that's stronger force, because effective nuclear charge, or Q1, Q2 basically, is on top of the equation, meaning that as it increases, it contributes to a higher Fe. That traveling across a period, increasing the protons will increase the force exerted on a particle if the distance remains constant. So now, an example, I want you to probably whip out a periodic table for this, and try to, instead of just using the periodic trend, try to reason in your head these answers. So order these elements in terms of increasing atomic radius, meaning start at the shortest and continually increase to the largest one. So pause the video for a second and try to do it, but I'm going to scroll down to the reveal the answer in like a second. So the answer would be carbon, boron, lithium, chlorine, sodium, and bromine. The reasoning is because these three elements are all in the same period, and carbon has the most protons out of all of them, meaning that at a constant distance, the effective nuclear charge of carbon is higher, and then boron, and then lithium last. And then we go down one more period to chlorine and sodium, where chlorine has a higher effective nuclear charge than sodium. And then we go down another period to bromine, which has the longest distance between particles. So now here I'm going to discuss ionic radius, where the concept is basically we're going to be comparing the radius of an ion to a normal element, or to another ion. So first, like, kind of rule to know. Let's say in the formation of a cation, what's going to happen is the atomic radius is going to decrease. Because when a cation forms, the metal, or like element, generally sheds its valence electrons, like it loses its valence electrons. Therefore, it loses an occupied electron shell, meaning that the new valence electrons are closer to the nucleus. And in terms of radius, I'm sorry I didn't explain this earlier, it's the distance between your nucleus to your valence electrons, or your valence shell. So yeah, so in the formation of a cation, the radius of the element is larger than the radius of the cation. But in comparison with anions, what's happening when you form an anion is your element is gaining electrons, which means a new shell of electrons is being occupied, meaning that the radius will increase because there's a larger distance between the valence electrons and the nucleus now. So now when we compare two different ions, say I'm comparing two cations right now, radius of sodium to radius of magnesium, or the ions, the ionic forms of them. So the reason that sodium will have a higher atomic radius is that magnesium has more protons, meaning that it exerts a higher effective nuclear charge on the particles in comparison to sodium at the same distance. But when we go to anions, what's basically happening is, we're comparing sulfur and chlorine right now, and chlorine has less protons than, or chlorine has more protons than sulfur, sorry, meaning that it has a higher effective nuclear charge. And also, since sulfur gains more electrons, we can use the concept that I reviewed earlier, shielding, or which basically just a term which it's talking about electron repulsion, and we can use that as a reason, just like in concept in our heads. And generally, another rule is that the radius of an anion is larger than a radius of a cation. So, thanks for watching, superstars, and I'm sorry this was a little brief video, but I really want periodic trends to be in its own video in a different style, so I could actually like utilize a periodic table and charts to like represent these trends and stuff, rather than just using like drawn notes like this video. But definitely expect future uploads coming up soon regarding AP Chem Unit 1 and future units contents. And that was it for today, and it gets better from here. Thanks for watching.